got to practice. Okay? You got to practice, just like everything else. You need to practice. The material, the mathematics in this class are not hugely difficult. But, as I've talked about before, it's all new. Okay? You've never seen a z-score. You've never seen a confidence interval. You've never seen those kinds of things. So, you need to practice it. Just as I could give you a two-step equation, should be able to solve that easily because you've practiced that throughout your math career. It becomes commonplace for you to do that. Confidence intervals, z-values, and stuff like that, if you continue to practice, it will be the same thing. We're going to go into the last section of work. We start working with hypothesis testing. When we work with hypothesis testing, it's going to look very similar to what we just did with confidence intervals. Okay, very similar. But now, once again, this is the final end and the conclusion to statistical analysis. You make a hypothesis, and you test your hypothesis, just like you have in science. When you're in science, you have a hypothesis. What is a hypothesis in science? An educated guess. Okay? It's an educated guess. And with that educated guess, you test your hypothesis through an experiment. Okay? You get chemicals out, or you do this, you add this and this and this together, and see, does my hypothesis work out? You test your hypothesis. Well, we do the exact same thing mathematically. You can make a hypothesis, you can test that hypothesis, but you do it mathematically. You look at data, you collect data, you get surveys, you collect data, you collect sample means, sample standard deviations, you collect all this data, and then you can test whatever your hypothesis is. So it's the exact same thing as what you do in science, but we're not getting test tubes out or Bunsen burners out. We're just looking at mathematical data. We just talked about confidence interval. It's an estimate for population parameters. When you talk about a confidence interval, we're getting two boundary values that we are estimating what's going to happen with the population. Once again, you will be, if you keep in social media at all or watch the news for the next 6 months, 7 months until the election, you're going to be inundated with polls of who's going to win the presidential election. They're all estimates. They're all dealing with a population parameter. They want to get as close to that population parameter as possible, but they're going to use confidence intervals to be able to do that. When you talk about hypothesis testing, once again, this is the final step to statistical analysis. It assesses evidence in the data for a claim about a population parameter. We make a claim, and then we test it. Just like you do a lab experiment in chemistry, or physical science, or bio, whatever, you make a claim and you test it. People that do analytical things for corporations, for businesses, stock markets, whatever, they have to make decisions somehow. And the decision-making process is that hypothesis testing for evaluating claims about the population. Smuckers, years ago, thought through their decision-making process, it was a profitable thing to buy dog food and Purina. And they went into the dog food business. They bought them up. Why? Because they thought that they can make a profit out of that. So that was their decision-making process, and they analyzed all the data, And the people that make all those decisions said, yes, this would be profitable for us to do that. They bought dog food. Okay? They kept that for maybe 10 years, 12 years. They eventually thought, you know what? We've developed this thing. We're going to look to sell it. We have somebody who wants to buy it that thinks the exact same thing, and they can make a profit, and we can make a profit off what we did. We bought something, and we sold it for a higher price. And they sold it to Post Cereal. Okay? Raisin Bran, if you get cereal boxes, you're going to have like Post Cereal. They make cereal. So now the cereal place is also a dog food place. You know, I sometimes struggle with that. You know, you make cereal over here, you make dog food over here. Hopefully they don't mix. But you never know, you might have a shiny coat of hair because of the dog food in your cereal. Who knows? That's what happened to me. I ate dog food when I was little. My brother said, here, try this. Got a shiny coat of hair, but it all fell out then. Statistical hypothesis is a conjecture about a population parameter. This conjecture may or may not be true. Once again, you make a test. You make a statistical analysis on it. So it's a statistical hypothesis, a conjecture about a population parameter. The conjecture may or may not be true. As we did confidence intervals about a parameter, we are 99% sure the population parameter is within these two values, which means you're 1% not sure. But I'm 99% sure that's going to happen. I don't know if you ever played cards, and when I was younger, we would play like quarter bets and nickel bets and stuff like that in card games. Well, the one card game was called In Between. The dealer would give you two cards, and you would bet, 50 cents or a quarter that the next card he turns up will be in between those two cards. But if you tied that card, if you say you had a 5 and a jack, you had to go in between there. Well, if you didn't, you lost your quarter bet or whatever. But if you landed on a 5 or a jack that turned up next, you had to pay double. So you would lose 50 cents. Well, when you have a 2 and an ace, this is the bottom value, this is the top value. So you have every denomination in between except for 2s and aces. Aces with the top, 2s the bottom. So you have the widest that you can get. The only thing you have to worry about is if that next card was a 2 or an ace, because you would have to pay double. So if you pay a quarter and it turns up a 2, then you have to pay 50 cents. Well, when you have a 2 and an ace, people tend to bet a little bit more because most of the cards, probability-wise, in the deck of cards is in between 2s and aces. So people will tend to bet more. They're 99% sure they're going to win. They're 1% sure they're not going to win. Okay, if they lose, they have to pay double. Well, that's the idea. I'm 99% sure that we're playing a baseball and a softball game today. JV's played today. 99% sure. We never know. You might have a rogue storm that comes through here and makes the fields unplayable, or something happens within the schools that it's better if we didn't play that day. So we're 99% sure we're going to play, but there's that 1% chance that we're not going to play. Hypothesis is typically an accepted value of the population parameter. If I drop this eraser, Sir Fig of Isaac Newton says it's going to get faster as it goes down, which means it's going to accelerate. Well, how fast, what's the acceleration of gravity? Anybody know in the science world?
7.
No. You're close with the 7 now.
6.
No, 9.81 meters per second squared. That's how fast it is. So it starts out at 0. Every second it's going to increase at 9.81 meters per second. So after 1 second, it's going to go 9.81 meters per second. After 2 seconds, it will be going 18.62 or 19.62 meters per second. So that's what an acceleration is. I say he's full of baloney. I know better than Sir Fig of Isaac Newton. Okay, he's full of baloney. Okay, I say 9.81 doesn't work. I say it's 9.54. I prove it, and I do a statistical analysis. So, once again, I make a conjecture about a population, may or may not be true. The accepted value would be Sir Fig of Isaac Newton, 9.81 meters per second squared. That's what we generally accept. We have 2 types of hypotheses here. You'll have to define these each and every time. You have a null hypothesis. A null hypothesis, which is a statistical hypothesis that states that there is no difference between a parameter and a specific value, or that there is no difference between 2 different parameters. This is a null hypothesis. Typically, it's the accepted value to test. What we accept is that Sir Fig of Isaac Newton, he said acceleration of gravity 9.81. That's what we want to test. It's typically an accepted value test. Or if there's no accepted value, it is what you're initially trying to guess. Most of the time, it's going to be an accepted value, but if you don't have an accepted value, you want to sit there and establish it. I want to test what I say is true. We also have the alternate hypothesis. The statistical hypothesis that states the existence of a difference between a parameter and a specific value, or states that there is a difference between the 2 parameters. Now, this alternate hypothesis, it depends on the books. Some books will say alternate hypothesis is H1. Other books will go in HA as an alternate hypothesis. So you have to sort of establish within the book what book you have. Okay, I will tend to go with HA a little bit more because I like it helps my brain. Alternate hypothesis. A lot of times with the alternate hypothesis, how we can simplify this is basically what we hope is true. The null hypothesis is an accepted value. The null hypothesis is accepted value. The alternate hypothesis, we want to say, no, that's not true. What we hope is true, we want the bottom value. That's what we hope is true, the alternate hypothesis. When hypothesis testing, we gather evidence against the hypothesis. We look for an probability of observing an outcome. And if the probability is significantly small, it leads us to doubt the initial claim, that null hypothesis. Now, our first steps in every one of our problems is going to be stating a null and alternate hypothesis. Okay, we need to state a null hypothesis, we need to state an alternate hypothesis. That's going to be your initial two steps. Before we go into any mathematical analysis, we need to state a null and alternate hypothesis. Now, most of these, for us, in this first part, we're going to be testing the population mean. We're going to be testing making a test for the population mean. So all these things we're going to be dealing with right now is we're going to be talking about just the mean, the population mean. A researcher thinks that if expected mothers use vitamin pills, the birth weight of their babies will increase. Okay? Now, when they want to increase the baby's birth weight, that's a positive thing for the baby because the more weight they have, they feel it's a little bit stronger baby. Okay? So they want to be able to increase that. The average birth weight of the population is 8.6 pounds. Okay? That's what the population mean is right now, 8.6 pounds. But if I take these vitamins, I hope to increase the birth weight. So if I take a look at increasing the birth weight, a lot of times what you want to do here is you want to start with the alternate hypothesis. Okay? The alternate hypothesis, because the alternate hypothesis is what we hope is true. So if you have a researcher or medical people that develop these vitamin pills, they want the birth weight to increase, and they want to sit there and commercialize that. If you take these pills, birth weights are going to increase. So all the pharmaceutical people will sit there and say, hey, take these pills, we'll make the birth weight of your baby increase. So what we're saying here is what they hope is true is that this population mean, mu, if we take these pills, is going to be greater than 8.6 pounds. And that's your alternate hypothesis. That's what we hope is true. If we take these pills, these vitamins, we're going to increase birth weight. So we hope it's going to get bigger. We don't know what it's going to be, but we know it's going to be bigger. The null hypothesis is the SpongeBob opposite day to the alternate hypothesis. What is the SpongeBob opposite to greater than? Less than or equal to. Less than or equal to 8.6. This is what we hope is true. This is SpongeBob opposite to it. Equality will always go with the null hypothesis. Equality will always go with the null hypothesis. Number 2. An engineer hypothesizes that the mean number of defects can be decreased in the manufacturing process of compact disc CDs, that's how old the problem is, by using robots instead of humans for a certain task. The mean defective disc is 18 per 1,000. We start with the alternate hypothesis. What does he hope is true? Mu is going to be what? Less than. What he hopes is true, what he is hypothesizing, is mu is going to be less than 18 per 1,000. Oops, less than. My bad. Null hypothesis, what's opposite to less than? Greater than or equal to. Psychologist feels that playing soft music during tests will change the results of the tests. He's not sure if it will raise or lower. In the past, the mean score is 73. He just says it's going to change. You might have people go, I don't want to listen to that stuff while I'm taking a test. I'm going to do worse. Or some people say, that's calming. Makes me focus a little bit better. So what does he hope is true? Less than or greater than. Well, how can we classify that as just one thing? If you're either less than or greater than, not equal to. There we go. Very good. So mu is not equal to 73. So the alternate of the null hypothesis would be equal to. Skip the next one. We'll go to the next 2 here. Okay, do the next 2. Chemist invents an additive to increase the life of the car battery. If the mean life is 36 months, he wants to have this additive. Okay, go ahead and do the last 2. Check your answer with somebody around you. First one, alternate hypothesis would be what? Greater than 36. So we have less than or equal to 36 here. See, a contractor wishes to lower the bills by using special type of insulation in the house. The average monthly bill is 78. So what does he hope is true? Alternate. Less than 78. And then we have greater than or equal to 78. Now, your homework for tonight, all you have to do is you have 5 problems. All it wants you to do with the 5 problems is right underneath the top there, write your null and alternate hypothesis. So you have all these words here. Sort of make it tight to the words in the problem up here, because once we start getting into the mathematical analysis, this is going to be a work in progress. Tomorrow we're going to start throwing some numbers in here where you'll actually start doing value work down here. So you need to do your null and alternate hypothesis close to the top here. And then so you have room to do work when we actually start doing the mathematical problems with it. So all you have to do tonight is just state a null and alternate hypothesis. This will be a work in progress types of problems here. We will continue to add to what you're doing here with hypothesis testing. All right, questions? All right, the rest of the time is yours.